Hi and welcome to my walkthrough on my array class. I was asked to make an array header file with methods without using any pre-made array without using any pre-made array class or header file that's based in C++. The first thing I did was I changed my constructor and my destructor slightly I changed them slightly because it had to be a dynamic array, so I've just changed that the number of elements is equal to the original size the person asks when they create the array. Then I create the array with 50% extra space, so it's more dynamic, so you can insert stuff and you don't have as much memory leaks and stuff like that. We were also two of the main methods we were asked to make were pop and push functions. The push function was simply just to push something into an already ordered array into the right part. So I use a binary search for it, so it finds the spot using binary methods. So what I have is a boolean just so I can make a do while loop, and the method will end then, and I don't return anything because I'm putting it into the array. I don't need to return the array or anything because the array is global. So I have an index just for the insert method, and then I have a low and a high for where it wants to search. So the high is equal to the number of elements already in the array. So if parts are taken out using the remove, which I'll get onto later, or inserted in, that number changes. So the place where I want the search to test from is starting at 0. But then I quickly change that down here to equal at the middle point of the array, so it's the number of elements divided by 2. Then what I do is I test to make sure that the array is in 75% full already. So then the array will resize to the size it is now plus another 50% before it inserts it in, to make sure that there is no memory leaks and there is enough space for this thing to go into without creating the memory problems. So this do while simply changes the test place from the low number, which is 0 right now, to the high, which is the number of elements, minus low, which is 0 at the moment, divided by 2, which is just the middle point. It needs to do that every single time because as you change the high and low point, you want it to change within a different region of your array. So first of all, checks to make sure that it's equal, and if it's equal to that point, then I ask you, do you want to duplicate? Because a lot of the time you don't want duplicates in an ordered array, as you just want to keep it once. If it is bigger, then the low number gets increased. So if you're just say there's 10 things in the array, if you're searching 0.5 now, and if you know it's an ordered array and the number you look for is 7, you're at the fifth point and you're going, right, everything before this is pointless. So you're moving your low point up to position 6 because you've already tested position 5. Everything before it is too low, so that's pointless. And then you're making that point 6, so when it goes through the next iteration of the do while loop, then it's searching between 6 and 10. And then the middle point of that is 7, or 8, or 7.5, which will give you a 7 because of the way computers do the math. And it'll check 7. No, it's not. And it'll search between 8 and 10, which will be 9, and find the slot that way. The high number is changed the same way. It's checking whether or not if the number is lower, it's going. Well, if the number is lower, it's just got to go and move the high point from where it is down to. So it's checked 5. It's going to move the number from 10 down to 4. Same way. If it's not higher, it's not lower, and it's not equal to, well, it must be in between the 2 points then. So it just inserts it in. I'll get onto the insertion method afterwards. If, as you can tell, you've seen this, the place true. What that is the boolean being changed to true, so the loop ends, and it's inserting there if someone wanted to, and it's inserting there into the position it's found. I'll get into the insert method in just a moment, but first of all I want to talk about my remove function, which is very similar to my insert function but just slightly backwards. Here's my remove. So what the remove function does is it needs to find the element you want to get rid of, which is the index they put in. So if they want to remove the fifth element, you want to remove that, but you don't want to leave that part blank. You want to remove that location and then move everything down one. So that's what that for loop is doing. It's taking that part into the array and going, okay, make the sixth one this one, make the seventh one the sixth, and all the way through. And then once that's done, I'm moving my number of elements down by one, like I stated before, just so there's less memory leaks and stuff like that. Because when you call size, you don't want, if there's 20 spaces, you don't want the number 20, because then you have a whole bunch of blank spots, and then the computer has to decide what the hell is going to be in them, and then it might get confused because there's nothing there. So what that does is, when you call for the size method, you're going to get the number of elements. So if you just go up to the insert method, this is slightly different. What I do first is, before the something insert, I do what I did in the push function. I check to make sure that there's enough space for it to go in. It's not too full yet, the array. So if it is too big, I resize 50%, like in the push. And then I do the same thing as I did in remove, except I'm increasing them all by one. So I'm starting at the end and going, right, go up one, go up one, go up one, go up one. And then I'm increasing the number of elements in the array by one. So if they insert, that number is bigger. So then if they called 6 inserts, eventually it'd be resized. Those are some of just the basic things, or the more complicated methods of just the basic methods that we were asked to make. Then we were asked to then make searches. So there's two different types of searches. There's binary searches and linear searches. The binary search is self-explanatory. You check the first element, second element, the third element, the fourth element, the fifth element, all the way to infinity for how big your array is. I'm just going to run to show you the difference between the two of them, the two searches. Make this full screen. If you look at the binary search, it took, no, that's wrong anyway. The binary search took 64 milliseconds there, because there must have been a change. If I just run it again, you will get different results. Yeah, that makes sense. What that did was, last time there was, the CPU did something and cancelled out in the middle of the binary search. The bigger the array, the bigger discrepancy you'll have between the two of these. If you look at the fact that the linear search took 44 milliseconds rather than the 7 milliseconds of the binary search, is because the 10th, the 17th, 15th, the 20th, and the 10, 17, 15, 20, and 18 were found near the end of the array. So it took much longer for it to get to those each time, when the binary search is very fixed in the time. There's not very much difference between finding the number 2 and finding number 20. It still has to do the same things, and it eventually finds them a lot faster than... It'll find bigger numbers much faster for that reason. The reason that is because, just like in the push, if we just go down to my binary search, it's just like the push in the fact that it has a high and low that moves, but it doesn't, if it's found, that's it, it's done, and if it doesn't find it, it returns -1. So I have the test place here, and I have the low number and the high number. The number I is used for this do while loop because it wouldn't work with a while true or whatever, like it would in Java or something. I couldn't figure out why that wouldn't work, so I just created the value I is 0 and then just said while I is not equal to -1, keep running this method. So what it does is, just like in the push that I've showed you before, we have the low plus the high divided by 2 to get the starting point. Checks if that's equal to it. If it is, returns it, nothing else. And then the end if it's bigger, or if it's smaller, move the low, or move the high number, so that should be backwards. Oops. Change the low. If it's lower, change the high value down. Actually, that worked. Yeah, sorry. So that's how they're both done. Then if either of them are found, just like in the push, you return -1. So that's everything on my array. class